अगला हफ्ता का पहले लेट हो गया। हाँ थोड़ा सा देख लिया। मेरे क्लास में नहीं हो पाएगा। ये वो होता मंडे को ये कोई करेगा। Yeah, hello Dhanunjay.
Yes, sir. Good evening, sir.
Dhanunjay, are you there?
Yes,
Okay.
sir. I'm there.
So in the last class, we had completed about relative velocity, right?
Yes, sir.
Yeah, we had done about relative velocity in the last class. Okay. So let's continue further. So we'll be doing, we can do acceleration or we have a little part of rotation. So in that, in the last class, we had also done about the uh, uniform circular motion. So in uniform circular motion, we had guessed if you discuss about the uniform circular motion at angular velocity. So here you have V equals R omega. This is the relationship that holds between angular velocity. Here omega is the angular velocity, or we also call it as angular frequency. Omega is angular velocity, or we also call it as angular frequency.
Sir, what is R?
R is the radius of circle.
Okay.
R is radius of circle in which the object moves. So this is the radius of circle. And V is the linear velocity. So it's something like this. Suppose you have a wheel of certain radius. Let's say so here I have a wheel which has a certain radius R. So now in this wheel, if suppose this wheel is rotating, so I hope you can see this is a wheel radius R and it's rotating with certain angular velocity. So if it is rotating with certain angular velocity omega given by 2 pi by t. So omega, the angular frequency or angular velocity given by 2 pi by t. And if it is rotating, so each particle on the circle, here each particle on the circle, on the circumference of the circle, it moves or it has a linear velocity. Its linear velocity will be given by v equals to r. You can also say the horizontal distance or the horizontal velocity that it can have. Let's say the linear velocity related with this circle will be equal to r omega. So as we can see, the wheels move, wheels rotate. So if wheels rotate and the vehicle is also having some linear velocity. So the linear velocity here is given by r omega, r times omega. That will be the linear velocity. Now here we have another concept that if you have acceleration, if this object is accelerating, so there are two types of accelerations that are possible. So you have here centripetal acceleration. You have centripetal acceleration. So centripetal acceleration is the acceleration even when the object is not accelerating. Centripetal acceleration, it acts even when the object is not accelerating. The object is moving with a uniform motion in a uniform circle. So even if your wheel is rotating with a constant angular velocity, an acceleration will be acting towards the center. So that acceleration we call as the centripetal acceleration. So the value of the centripetal acceleration is given by the value of centripetal acceleration is given by v squared by r. So it's given by v squared by r, or you can also use the value of v as r omega, and obtain the value of centripetal acceleration. Okay. So the centripetal acceleration, it can also be, if you squared it, so you'll get r omega squared. So centripetal acceleration given by A equals V squared by R, or it is also equals to r omega squared. If you substitute the value of V as r omega, so you get the formula as r omega squared. So here the centripetal acceleration is obtained by this formula. Centripetal acceleration, it is always required by the object to be moving in a circle. So every time there will be a centripetal acceleration which will be v square by r. So all the objects which are moving in a circle, they require this centripetal acceleration. And hence there will be a centripetal force also. Centripetal force means a force which always act toward the center. So we'll see how the centripetal force can be calculated and where all it is required, how the objects require the centripetal forces. So in the last class, we had seen that the acceleration which is required is always towards the center, and that acceleration we call as the centripetal acceleration, which is v squared by r. So wherever you have acceleration, a force will be required, and hence you can obtain the value of force, which we call as centripetal force. So our centripetal force would be given by mv squared by r. So this is the value of centripetal force. V squared over r is the centripetal force. Now it is also equals to mr omega squared. You can also write this since the acceleration is either v squared by r, or you can write it r omega squared. So centripetal force, since force is given by mass times acceleration. The simple way, it's mass times acceleration. So it will be given by m times acceleration. Acceleration was r omega squared, or here it was v squared by r. So let's try to have rotation of, let's try to revolve a stone tied to a string. So here we have a stone which is tied to a string. So to make this stone move in a circle, if I have a stone and I tie it with the help of a string, so if this string moves in a circle, here this is the center O, and the stone has some mass m, and suppose it's rotated with certain angular velocity omega. So if you want to rotate it, you must apply a force on this mass towards the center. So what all things are there? You have to apply a force towards the center, which is the centripetal force, to keep it moving in a circle. So if it has a certain velocity, if it's moving with a certain velocity v or certain speed v, so as we know the velocity will be perpendicular to the force. During a circular motion, the centripetal force is perpendicular to the direction of velocity, and hence our centripetal force will be used every time to change the direction of velocity, and it will not bring about any linear acceleration. So there will not be any changes in the speed of the object. The speed of the object will remain constant. Just by applying the force, you will be able to move it in a circle. Okay. So our force which we require is mv squared by r, that is centripetal force. So just like it's not possible for us to rotate a stone tied to a thread in a circular path without having the involvement of a rope. You must have a rope, you must have a thread, and must apply your force to the mass with the help of that thread or a rope. So your force is acting on it towards the center, which is providing it the necessary centripetal. And your centripetal force here is equal to mv squared r. In the similar way, if you consider the rotation of Earth around the Sun, so the rotation of Earth around the Sun is also a circular motion, and during this circular motion, whatever uh, centripetal force is required, so that centripetal force is required by the gravitational forces of the Sun. So here we can write down that the gravitational force of the Sun is pulling the Earth towards its center. Here we have the gravitational force that is pulling the earth towards the center okay, with a force, and this force with which the sun is pulling the earth is the force which provides it the necessary centripetal force. So the necessary centripetal force F should be equal to mr omega square, and it must be equal to, so this mr omega square should be equal to uh, the gravitational forces. So here the gravitational force between sun and moon we know is given by F equals gmm by r squared. So the two forces must be equal to each other, and from this you can also obtain the Kepler's third law. See, the gravitational forces are the forces which apply between these two objects, and they provide the necessary centripetal force. So from this I get mr omega squared should be equal to gmm by r squared. There is no other force that is acting between them. This mass is mass of the earth, so that gets cancelled. You have g and m are the constant, and since you get here r cube will be equal to gm by omega squared. If you put the value of omega, we get the value of omega as 2 pi by t. So from here you can obtain the relationship. You can get r r cube will be equal to gm over 4 pi squared, and here you will have t squared. So g and m are constants. M is the mass of sun, which is constant here. 4 is also constant and pi is also constant. So from this, we obtain our r square is r cube is proportional to t square, or you can say t square is proportional to r cube. So this is what we studied in the Kepler's laws of planetary motion. So everywhere when you observe an object is moving in a circle, so for its movement in circle, it must require a centripetal. Without the centripetal force, it's not possible by an object to revolve in a circle. Okay. So such are the centripetal forces everywhere. Suppose if you have a car taking a circular turn, let us try to understand a car taking a circular turn here. So you have a car taking a circular turn here. Now let's say it's rotating in a circle, and so as we observe that the movement of the car is circular, right? Dhananjay? We observe that when the car is moving in a circular path, so its movement in this direction is circular in nature. It is going in a circular path of radius r, and suppose you have your car here. So definitely the car requires some amount of the uh, we can say centripetal force, right? So who is providing the necessary centripetal force for the car? Can you guess where do we have the centripetal force? Since the car is moving in a circular path, so who is where or how we are providing the centripetal force? Because without the centripetal force, the car would not rotate in a circle, not revolve in a circle.
Yes, sir.
So here, assume here that there is no friction between the tires and the road. If you have no friction, so the tendency of the car would be to move out in the outward direction. The car would tend to move in the outward direction. It would tend to move straight without any direction changing. The tendency of the car would be to move tangential like this, and hence after some point you will observe that the car is moving out of the road. car is moving outside the road. So here, since the car moves outside the road, but it is a friction between the tires and the road that holds them together. So the friction between the tires and the road, it holds the car or it doesn't allow the car to go away. So here, the necessary condition, what is being provided as the centripetal force, is the friction between the tires. So here you have the frictional force between the tires and the road that provide the necessary centripetal. Okay. Had there been no friction, so car would not be able to take a circular turn here. So here you have the necessary centripetal force which we require mv squared by r. So mv squared by r is equal to the force of friction. Okay. In the similar way, we also observe different cases. We have seen different cases where some centripetal forces are required. Okay, like if you try to mm, so let's say you have an object or a cycle taking a circular turn. Okay, so when a cycle takes a circular turn, over there also you have the over there also. So, okay, let's see a pendulum here. As we have seen, a pendulum also makes a circular motion. So you have a simple pendulum here, and the pendulum completes the necessary centripetal. It completes about half a circle or whatever circle it completes. So your pendulum moves in a circular path. So now, since the pendulum describes a circular path, so it must require a centripetal force. The centripetal force required by this should be acted towards the center, and this is you have your tension in the rope becomes tight due to the presence of weight. So here gravitational force or weight is acting in the downward direction. Because of the weight, there is a force of tension in the rope. So this force of tension in the rope is the force which provides the necessary centripetal forces. Okay. So every point, any object you observe revolving in a circle, there will be a centripetal force. Now, if the object starts accelerating, if the object has an acceleration in a circle, so there must be some external torque acting on it. Okay. So when some okay, so you have some other. So I hope you have understood about this centripetal acceleration. All the objects which are revolving in a circle, to revolve in circle, they require a centripetal force. And also, the objects experience a centrifugal force. If you observe the centripetal and centrifugal, they are the same forces, but with respect to different perspective. To an observer who is sitting in this frame of motion, the object will seem to have a centrifugal force. It will seem to experience an outward force. Okay. Whereas if an object is outside the frame, it will seem if it is moving in a circle, so there must be a force acting towards the center, and that is the centripetal force. Okay. So centripetal and centrifugal, they are same, acting on the object, but with reference to two different perspectives. Okay. If a person acting from here observes the motion, so it must experience a centrifugal force. If a person observes from outside, so it must experience a centripetal force. Okay. So now let's talk of angular acceleration. We have another term, angular acceleration. Up to now, we have talked of uniform circular motion. Okay, so you have angular acceleration. The angular acceleration means how fast an object is rotating about the center. About rotating, how fast the acceleration is achieved in angular velocity. That means how fast the angular velocity is changing. As we know that the angular velocity, so angular velocity is given by omega. It's given by omega. So we can write angular acceleration means how fast the angular velocity changes. So you have angular acceleration. Angular acceleration is denoted by the symbol alpha. So you have angular acceleration alpha given as, we write it as d omega by dt. Means how fast the angular velocity changes with respect to time. Call it as angular acceleration. So suppose when a vehicle is speeding up. So if you have a vehicle speeding up, so the rotation of the car increases. The angular velocity of the car increases. So it will have a positive angular acceleration. In a similar way, if you observe application of the brake, so we observe that the rotation of the car decreases or angular velocity of the car decreases. So we will have angular acceleration. So if there is an angular acceleration, if there is an angular acceleration, so due to angular acceleration, there will be some linear acceleration also. Okay. So the linear acceleration or translational acceleration that we observe here, translational acceleration. So translational acceleration will be given by A is equal to R times alpha. R times alpha. If alpha is the angular acceleration, so angular acceleration multiplied with the radius will give you the translational or the linear acceleration. So we'll come across all these terms, but this was all about the angular motion or revolution in a circle. Okay, bye. This one.
Bye, sir.
So tomorrow we'll have the last class for it.
Okay, sir. Thank you, sir.